After searching far and wide, I've found the perfect chassis for a vSphere cluster, or the perfect vSphere cluster solution, because I'm not necessarily limiting myself to just one chassis. It just so happens to be one chassis. That's the Tyan Transport CX. Let me show you. You might have seen our full review and, well, overview of the chassis and what the hardware offers. This is one of 4 nodes in a 2U chassis from the Tyan Transport CX. This is a single socket AMD Epyc. It's designed for Rome and Milan, although my recommendation is going to be for Milan, of course. A single socket solution. You got all 8 DIMMs, so you got all 8 channels. You got 2 PCI Express by 16 slots, 1 OCP2 slot. You can rock up to a 25 gigabit Ethernet adapter with that. So you got 2 built-in 1 gig NICs, IPMI, of course. You got the redundant fan array, redundant fan configuration. You got 4 2.5-inch drives at the front. Depending on which Transport CX you get, it could be NVMe, it could be SATA. Our configuration here is with NVMe. We've got a killer cluster, but more on the VMware side of it in a minute. We have a built-in RS-232 header for debugging, power, and reset on board, just in case you need to debug one of these. You can actually run one of these outside the chassis with a 12-volt input adapter. You've also got onboard SD. Now this is through the ASpeed 2500. I don't know what you're thinking. Oh, it's through the IPMI. I'm not going to be able to use that for the hypervisor. You're wrong. I wrote a guide. It's on the Level 1 forum. You can check that out. You can use the ASpeed 2500 both for the onboard error logging, like the video capture and the cool features of the ASpeed 2500, as well as the hypervisor. Hang on a second there, past self. Technically, VMware doesn't recommend the use of SD or USB cards for the host installation anymore. You can use one of the disks and store ESXi that way. The reason is that over a 5 or 10 year time scale, an astronomical amount of support for end users is on, oops, the USB or the micro SD stopped working. So keep that in mind. These chassis from Tyan do support iSCSI right in the BIOS. So if you otherwise have a SAN, you can store your hypervisor on that. And that also makes scalability a little easier. There's also more stuff that you can do with the ASpeed 2500 through SSH to manipulate that SD card, but getting into that is a little outside the scope of this video. The ASpeed 2500 really is an incredible full-featured out-of-band management solution with the dedicated IPMI port on this platform, and so you should definitely check that out. There's a lot of cool documentation. Come to the forums, I'll try to help you. Cool stuff. Anyway, single socket. Single socket is cool for AMD Epyc because you can use the P series CPUs. Epyc is available in P and non-P varieties. And at the really top end, like the 64 core, the only difference is price. For some of the other P series SKUs, clock speed and some other parameters may factor in there. You can get a P series SKU for less than its non-P counterpart, which works great in this chassis. This chassis technically has 4 sockets, but each system is its own server. It's completely independent. The only shared resource is the power plane, and there's 2 redundant power supplies there. And it's so elegant and clean, putting your complete vSphere cluster solution in a 2U chassis. It's so awesome. Now we really need to go to the whiteboard to look at how this is going to look from a topology standpoint. But before we get to the whiteboard part of it, let's take a look at our hardware so that you know what my mindset is. So I'm thinking about, of course, vSphere clustering. That's a given. But also vSAN. And this chassis actually gives you more options than you might realize in terms of a vSAN solution, especially if you're going to go with an all-flash vSAN solution, which is what I highly, highly recommend. And yeah, I know there's still a place for spinning Rust. You can add spinning Rust to this, but we'll talk about how at the end of the video. So if you need the capacity of spinning Rust, yes, I got you. Just give me a second. So in this configuration, I've got my basically old news P4500 SSDs from Intel, and they're 2.5-inch, and that's great. And I can have 4 of them, 4 terabytes. I mean, you can get them up to 15 terabytes now. I've got 4 of them at the front. So just imagine that for a second. It's a fully populated system, basically. They're hot swap. Here, I've also got a 375 gigabyte Intel Optane. That's deployed on an M.2 solution. There's a second M.2 slot back here, and I could run 2 Optane. So when we're thinking about vSAN, and we're thinking about the fact that I've got 4 of these nodes in a chassis, you've got some options. Every node that's participating in the vSAN cluster ideally has both capacity tier storage and cache tier storage. So what I've done is configure the other blades to use the 4 U.2 connections in the front, or 2.5-inch SSDs basically, as the capacity tier, and to use the single Optane device as the cache tier. Now vSAN behaves a little differently depending on whether you're using flash and spinning Rust or just all flash. In this configuration, because it's all flash, and these devices are on the VMware approval list after all, it will use the capacity tier for reading as well as writing, but it will cache writes to the Optane. So any writing that has to be done will be done through the Optane, which has a very low latency. It's a very excellent device for this sort of a use case. And then those writes will get flushed out through the Optane to the capacity tier according to your storage policy. And with 4 drives, we can do a storage policy that's equivalent to RAID 1, it's equivalent to RAID 0, that's equivalent to RAID 10, depending on what you've created in vSAN. vSAN is a smart enough technology that it knows how to balance the storage tier on a particular node to ensure that you have good performance. Now, strictly speaking, you could have nodes that don't actually have storage that get it over the network or through iSCSI or something like that. That's a whole other conversation that we could have, and with high-speed networking like 25 gig Ethernet, you could definitely do that with these nodes. But I'm not talking about that. I'm sort of talking about the everyman vSphere cluster with vSAN. Hyperconverged, this is hyperconverged. When we talk about hyperconverged, this node in this configuration is hyperconverged. Now the other really cool configuration you could do with vSAN is add a second Optane, and then you have 2 of your U.2 as a capacity tier and another U.2 as another capacity tier, each of which have their own cache device, their own independent Optane. When it's configured this way, the loss of a cache device really isn't fatal. You're caching writes, and that's annoying that you lost some data there, but ultimately those writes are flushed out to your storage. Not a big deal. Depending on what your storage policy is, if you lose a single U.2 device, that information was probably mirrored somewhere else in a failure domain, depending on what the failures to tolerate configuration is in vSAN, depending on your storage policies, basically. So the storage policy really sets a performance aspect as well as a redundancy aspect. And so information will be stored on other nodes on your vSAN cluster according to whatever your storage policies are. Because vSphere is basically planning for the complete loss of a node. Usually that doesn't happen, but you've got 4 nodes in a chassis, you can do it. Now, the vSphere documentation for clusters and vSAN still says that it can get by with a 2-node cluster. But really, I'm just gonna tell you, forget the 2-node option. I was kind of sort of ghetto fabulously doing that several videos ago, like last year, and you could use, your actual SAN as a witness device. Don't do that. That's coloring outside the lines. That might be fine for a home lab, but that's not really great for a production instance or a production installation. With 4 nodes, you could lose 1 node. You still have 3 nodes. vSAN is going to continue to operate and be perfectly normal and completely fine. And you actually could even support failures to tolerate 2 type storage policies, which is an even better level of resilience and redundancy. Another thing that I would note here real quick is if you're looking for failures to tolerate 2, a 4-node setup isn't technically supported. Theoretically, if you could mirror a VM across all 4 nodes, any 2 nodes could fail. Like a RAID 1 type mirror. It's going to take up 4 times as much disk space. So if I've got a 100 gig virtual machine, it's going to take up 400 gigs of space across all of vSAN because it's going to physically exist in each physical node. But VMware says that's not really supported. That's not a thing. They don't recommend that. So if you want to do failures to tolerate 2, you actually would want a 6-node cluster for that. There's not really a recommended or sanctioned way to do that on a 4-node cluster. At least the VMware experts tell me. So bear that in mind. Hey, just get 2 chassis, and then you've got 8 nodes, and you're in a lot better shape. That also solves the other problem, which is usually when something goes horribly wrong, it goes horribly wrong in a rack. And so if you have another one of these nodes in another rack somewhere else, it's probably going to be more survivable should something catastrophic go wrong. Now, with 4 nodes in one rack and 4 nodes in the other rack, if you lose an entire rack, that's not enough nodes to keep the cluster going. Not at all, because there's not really a way to do failures to tolerate 4 with 8 nodes. But you do increase your chances. And it's just a best practice having as much infrastructure distributed across as many racks as possible, just for peace of mind. So you think about a pretty pedestrian solution with this, 16 terabytes of flash in each node, 4 nodes. That's a heck of a lot of flash on board. And that's with, 4 terabytes. You can get these drives up to 16 terabytes in capacity, roughly $100 to $200 per terabyte, with Optane being, around $1,000 a terabyte. But still, this is a really, really incredible setup. Being able to use the OCP2 slot for 10 or 25 gig, or the PCI Express X16 slots for 25 or 100 gig, give you a lot of flexibility to take that out to other chassis as well, depending on what sort of connectivity you need. If you wanted to, you could go to a PCI Express backplane with 32 lanes of connectivity to, hot compose in GPUs and FPGAs and machine learning accelerators and all kinds of stuff, and still have 4 nodes that are tied into all that. Western Digital's got some really interesting stuff going on with that, but that's you're gonna have to check out the Liquid interview video for sort of a preview of that and some of the stuff that they're working on in terms of composability. But this chassis as a front end for some composable solutions could be pretty exciting. But I digress. Anyway, storage policies. So you could create a storage policy that has your mission critical virtual machines replicated to every single node in the cluster. So things like Active Directory or DNS service or whatever. So you have the entire virtual machine, because it's presumably, DNS, Active Directory, those virtual machines are probably not very large, probably on the order of a couple of 100 gigabytes, if that. You replicate that to every single node, and you're guaranteed that no matter what sort of failure you're experiencing, that virtual machine is going to be available on every single node. You just set the policy. Instead of having a single storage volume that's RAID 5, or a single storage volume that's RAID 6, or a single storage volume that's RAID 10, you set the policy on the virtual machine, and the software takes care of managing everything to do with that. It'll figure out, it's like, oh, I could probably stripe this across all of the SSDs as long as I'm replicating it somewhere else over a high-speed network, and that'll be completely okay. It'll do that, and it'll perform really shockingly well because the software is really intelligent. You can get the debugging tools out and actually, sort of figure out how it's doing that. Sometimes you do need to fiddle with stuff under the hood, like it's not magic. You still have to sort of look at it and make sure it's doing the right thing. But most of the time, it actually does do the right thing, and it's seriously impressive. Now, the other big thing to figure out with this is, because these are 4 separate machines, how do you network it and cable it? Well, for that, we've got to go to the whiteboard. The whiteboard! Okay, so if you purchased an enterprise switch, or been looking at enterprise switches, you might have noticed that it's kind of this bifurcated design now. Switches like our Dell 25 gig / 100 gig switch, they come in halves. You don't even buy a whole switch anymore. It's just a half a switch. It wasn't just a trick to make switches cost twice as much. It's a single rack unit, but it only takes up half the space. But the reason is redundancy, because everybody but you is running a cluster like this. And this is our Tyan Transport CX, if this gives you any idea. Now, these are our 2 built-in 1 gig ports. This is our management port. Don't forget, we've also added the OCP interfaces here. Pro tip, always opt for the dual interface cards. Don't ever opt for the single interface cards. This is partly why. So we've got our 2 10 gig interfaces and our 2 1 gig interfaces. For a cluster like this, believe it or not, the 1 gig interfaces being sort of the network facing, like the rest of the network, the normie facing network, 1 gig or 2 gig is fine for this interface, because most people aren't really doing a lot with the virtual machines. For storage heavy stuff, these 10 gig interfaces are nice, and they're nice to be able to communicate between nodes in the cluster, and they're nice from a storage standpoint. Now, you can configure vSAN to only use one of the connections at a time and then put everything else on the other connection. Or you can sort of mix and match if you want things like vMotion, which will let you move virtual machines from one node to the other, even while they're running, which is a really cool feature, while not affecting the storage interface. That's a you decision. Just know that you've got a lot of options. For redundancy and cabling, this is probably how I would set it up. So I don't really want to draw the rest of the lines, but every single node, because it's its own independent computer, would have 2 connections to your switch. And so one side of the switch and the other. And theoretically, you've got, a jumper cable or a bridge cable or something that's making each of those halves work together. And then each one of these usually also has a redundant power supply as well. So your switch has 4 power cables. So, well, it's 2 halves. You can do a lot with that. The idea is that if this switch goes down, everything is still connected to everything else. If this node goes down, everything is still connected to everything else. That's basically the idea. It's not really any more complicated than that. Now, they do make OCP cards that are 4 interfaces. Those can work really well. I would suggest that if this is not substantial enough for your needs, that you still use the 10 gig interfaces here, but you could use them for the customer facing side and use 25 or 100 gig connections here. I've actually picked up a couple of dual port 25 gig cards. They're just PCI Express. They're not OCP2. And I'll be able to use them in these nodes because remember, they have the 2 full length 16x expansion slots. Some people are still really excited about fiber channel. You could do that if you really wanted to for the storage side of it and have the vMotion be on an entirely separate network. This is actually sort of a fun side conversation about VMware products in general, because depending on what you're doing, it might make a lot of sense to actually separate out the vSAN network from anything that vMotion and some of the management and some of the other services might run on. There's like 5 services in all that you could run over the LAN side at 1 gigabit, not recommended for vMotion, 10 gig, which, that'll run at a gigabyte per second. You can aggregate these together, and most stuff in VMware is designed to have 2 links for redundancy. And if you have 2 links for redundancy going into different switches, but are part of the same collision domain or subnet or ever how you want to refer to that, then that's a pretty good idea. That works pretty well in practice, because if this dies, everything still remains connected, because vSphere knows. vSphere will look at this and say, oh, this link went dead. Is everything up still on this side? Yes, because on the software side, you've configured that redundancy. The software-defined infrastructure basically handles the hardware failure completely transparently. That's why you do this, is because something has died horribly, you might not even notice. So there you have it, the networking aspect of it. Well, one tiny slice of the networking aspect of it. I mean, there are going to be people that tell me that every different function that's available in the vSphere cluster needs its own interface. And they're not wrong. I mean, there are situations where it makes sense to do that, for sure. But this approach to hyper-converged infrastructure with some really serious software-based resiliency works well. And VMware is finally catching up with technologies like vRealize and Kubernetes, well, Tanzu, but they're probably going to have to make those not add-ons. They're going to probably have to make those available at the pleb tier, and the hobby license, the hobby home license, that's a couple $100 a year, so that people can play with those, because those are really cool technologies. vRealize and Tanzu is really awesome stuff. And playing with it on a cluster like this is really awesome stuff, and it would help your enterprise and your business and things like that. Now, spinning Rust. How does spinning Rust fit into the equation here? Well, on the 10 gig side, you can add an interface for that, or add that to your 10 gig network, so that you can have another chassis that has spinning Rust in it. And 1 or 2 10 gigabit interfaces, we're talking about 1 to 2 gigabytes per second on your iSCSI interface. That's not terrible. With 2 25 gig interfaces, now we're talking 2.5 to 5 gigabytes per second. That's really, really good for a spinning Rust array. It's usually the latency, not the throughput, that kills you anyway, because most things are not using that much throughput on an ongoing basis. So if you want to do that, there's the Synology Uc 3200. It, like this, is dual node. Yes, 1 chassis with 2 Xeon servers in it, dual attached to SAS drives, so there's a redundant path to each drive. Basically, 1 physical hard drive actually connects to 2 servers in 1 chassis. Yeah, this is Synology Uc 3200. I've got a separate video coming up on that. And that is actually kind of a critical piece, maybe, because you may not have something for your backup solution either. And something like the Uc 3200 is a really incredible solution for this. VMware has had some security issues with their products lately. There is a patch for vSphere. If you haven't patched vSphere in the last couple of months, it's a really bad remotely exploitable vulnerability. You should not be watching this video. You should be patching vSphere. if you haven't already patched vSphere, because it's that bad. You know, they could be mining Bitcoin on your cluster. You don't even know it, or worse, exfiltrating data. You can store backups and snapshots and information outside the cluster with Synology and the UC3200, but that's going to be in the next video. So get subscribed, stay tuned, comment below, join us. I'm Wendell, this is Level 1. This has been a quick look at the Tyan Transport CX for VMware. It is the perfect VMware hyperconverged solution in 2U, in my opinion. Yes, you could run a solution like this in 3 or 4 or 6 or 8 normal machines, normal 1U, 2U servers. Yes, you absolutely could do that. But I love this. I love having 4 nodes in 2U. It's the sweet spot because that's the VMware cluster, that's the solution. And any other nodes I need, well, they can be out living in the cloud because that's how I roll. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums, engagement challenge. If you're using VMware or curious about VMware or want to know anything about hyperconverged infrastructure or some of the automation tools around it, because automation is coming to eat all of our lunches in a good way, comment below. I'm signing out, and I'll see you in the Level 1 forums.